left home and ran to the lake at 10 miles an hour. She ran back home at 8 miles an hour. If the entire trip took 27 minutes, how far did she run in all?
All right, so we have a time, we have a rate. If only there was an equation that related rate, time, and the distance that she traveled. If only that. You're saying it does exist? Yes? Yeah, okay, what was it?
Rate times time.
So rate times time equals distance. Okay, that's really helpful. I could swear that we've seen some charts in the past, right? We've had a couple problems with some charts in them. So let's make a chart. Now, how many runs do we have in this problem? 2. Okay, we have 2. So we have to the lake, and we have back from the lake. All right, so let's fill in the information that we happen to know. Lily, what is the rate that Lori ran to the lake? 10 miles an hour. That's pretty good. That's 6 minutes per mile pace. Not half bad. What is the rate that she was able to hold coming home from the lake? What? 8 miles an hour. That's 7 minute 30-second pace. Again, that's pretty solid. All right. Okay. Do I know the time? Do I know the time that it took for her to get to the lake? No. Okay. So if I don't know something, what am I going to use? A what? A question mark? A variable. We want a variable. What letter shall we use for a variable for time? T. Okay, that makes sense. All right, and do I know the distance that she traveled?
27.
No, not 27. That's 27 minutes in total. Do I know the full distance? No, I don't know the full. But wait a second. Rate times time is equal to distance. 10t. All right. Now we're getting somewhere. All right, so great. So if it took t minutes to get to the lake, and it took 27 total minutes to get there and back, how long did it take to get back from the lake? 27 minus t, because it took 27 minutes minus the time it took to get to the lake, and that's going to give me my time home from the lake. So we have 27 minus t. So what is my distance coming back from the lake? Walt? The answer, please? Oh, yes. Okay. Your forehead is great. Let's. Yeah. Okay. So based on rate times time equals distance, what is the distance home from the lake? 8, and what are we doing with 8 and 27 minus t? Okay, we're going to multiply them. All right, and what can you tell me about the distance to the lake and home from the lake? It's the same. Okay, so what can you say about these two expressions? They're the same? And in math, what do we say when things are the same? They're equivalent. They're equal. So we can say 10t is equal to 8 times 27 minus t. All right. So right now, I would like you to solve for t.
Okay, so what I first did was I made the train tracks, but the first thing that I did was I distributed this side. So 8 times 27 was 216. And then it was minus 8t. And then this was still 10t. And then the next thing I did was I know you have to get the t on the same side of the equation. So I added 8t here. and added AT here, which got me 18T. And then I had 216 over here. And then I divided both of these by 18, which got me T. And then 216 divided by 18 was 12. So I said that T was equal to 12.
So we now know it took 12 minutes to get to the lake. But wait a second. This is 12 minutes. This is miles per hour. That's not the same units. So how many hours is 12 minutes? It's 1/5 of an hour, because 1/10 of an hour is 6 minutes, so 2/10 would be 12, and 2/10 is 1/5. All right. So how far is it to the lake if she ran for 1/5 of an hour at 10 miles per hour? It's 2 miles. If it's 2 miles to the lake, how far is it back from the lake? How long? Two. It's still 2 miles. I'm a little concerned about this group. If only 3 people have figured this out. It's the same both ways. All right. And so what is the total distance? 4 miles. So the